Hello everyone, this is Shovik and you are watching college level physics. Today I am back after a very long time, and today I am going to give you a brief review about the book called Introduction to Quantum Mechanics by David J. Griffiths as well as Darrell F. Schroeter. And this is the third edition of this book. Now, in the second edition, there was not this chapter called, where was it? The symmetries and conservation laws. This part or the chapter 6 is added to this third edition, as well as some new problems are added in this edition, which will be very much helpful for students as well as teachers who will teach or learn quantum mechanics. So this is a very famous book by David J. Griffith after the electrodynamics books, and David J. Griffiths is one of my favorite author in physics. So let's see what the contents of this book is. So this book consists of these chapters called the wave function, where you will get some basics or properties of the wave function, and then comes the time independent Schrodinger equation, which is a preliminary or is covered in bachelor's of your course. And then comes the formalisms, that means it contains Hilbert space, observables, Hermitian operators, and so on and so forth. And Dirac operators, actually it is a linear algebra part this chapter covers. And then comes the quantum mechanics in 3 dimensions. So you have to go from 1D to 2D then 3D. So there are these parts which are radial equation, angular equation, and then obviously it has hydrogen atoms in it. And then you have some chapter called identical particles, where you will learn about bosons and fermions, their wave functions, the plus minus signs, and so on and so forth. Then comes the 6th chapter, which is called the symmetry and conservation laws. Now this part is one of the most important portion in this book or in quantum mechanics course, where you will learn about parity, the selection rules, the conservation laws of energy, momentum, angular momentum, and so on and so forth. And then comes the application part, where you will learn the time independent perturbation theory. Actually in nature you will see a lot of perturbation. There is no ideal situation in nature. So then comes the variational principle. Then also in the perturbation theory you will learn about Zeeman effect, the Stark effect, the fine structure and hyperfine structure of hydrogen, if you can see these parts. And then comes the variational principle, then WKB approximation, then one of the most important part like scattering theory, where you will learn about Born approximation, first and second Born approximation, and so on and so forth. Then there is a quantum dynamics, where you will learn two-level systems, time-dependent perturbation theory, and emission absorption of radiation, Einstein AB coefficient. Actually this part is mostly for laser part. Then the most important part in this chapter is the Fermi golden rule, or then the adiabatic approximation, which will be useful in further applications of quantum mechanics. Then comes the EPR paradox, Bell's theorem, mixed state and density states, pure state mixed state, no cloning theorem, Schrodinger's cat, which will be mostly useful in quantum computing course if you take, or otherwise you will have the basics of it. So also there is a linear algebra part at the end of this book, which will be useful in dealing with Dirac algebra. So let's see some of the parts of the chapters. I hope you can see clearly. So there is the preface. Now part 1 is theory. Here is the wave function part. So you can see the Schrodinger equation, then comes the statistical interpretation, Born's interpretation of wave function, the probability density. Then you will see like this, there are so many analogies of this wave function. You will definitely enjoy it while reading this book. And also the best part of this book that it has a lot of problems after each section actually. So you will learn more when you solve these problems. Then the normalization part, also you can see the problems is present here. Then comes the momentum part, and there are also some analogies of it. Then comes the Heisenberg's uncertainty principle, and so on and so forth. So this is the basic of it. Then comes the time independent part, Schrodinger equation. So you can see this. I'm just in a hurry, so I will just skip it through it. There is an infinite spiral potential, which you will find in most of the books. It is solved here. So there is also some problems regarding it. Then comes also there are some examples. You will learn most of it while going through this exercises and problems. Then comes the harmonic oscillator, the mostly used problem in quantum mechanics. So this is nicely depicted here. There is an algebraic method as well as another method I think has, which is analytic method. Yes, you will get a detailed analysis of these two pictures here. So as you can see, there are graphs for your understanding, problems are there. Then comes the free particle part, which is also solved in a detailed manner. And then comes the example, or you can say problem, where it is solved. Also the group velocity, phase velocity part is there. It is nicely explained here. Then comes the delta potential, which is one of the essential part of quantum mechanics. Just going through it, there are lots of problems. The infinite square well. Then it's a lot of problems, you can see. Let's try to solve them. I will try to upload some of these problems in the meantime. So this is the formalism part. I will just skip through it. So yes, you can see uncertainty principle and time energy. Then comes the three-dimensional part, where there is a detailed description of these angular equations. How can you solve it using Legendre equation? Then the radial part is there. The solutions are also given. It's the Bessel function. Then comes a hydrogen atom problem. So how you can solve this problem and get a solution is also given here. So after solving, you will get this kinds of wave functions as well as the energy. So this is the pictures of it. So yeah, there is also some more problems of it. Now this is the Stern-Gerlach experiment. Then go to the these are the like WKB approximation, the detailed picture of it. Then comes scattering part. You will get detailed analysis of this in this book, and also the pictures are given so that you can think or correlate this mathematics easily. So yeah, these are the two level system as I told you. Like the laser is also given here, some brief of it, the population inversion, then comes the Fermi golden rule, and then comes the adiabatic approximation. So yeah, there is also some problems of it. Then comes some brief chapter on EPA paradox, Bell inequality, the density matrix, the no clone theorem, Schrodinger cats, and this ends here. The appendix part contains the linear algebra, which should be very much helpful in the quantum mechanics 2 course if you take. So at the end, I would suggest this is a best book to begin with quantum mechanics, and just solve the problem so that you will get an idea on the basics of quantum mechanics. And there is a lots of other advanced level books, Sakurai and other books are there. Just if you are beginning if you are just started quantum mechanics course, so you should read these books. This will be very much helpful, and also you can have a look at other books too. So that is all for today. I thank you for watching. Take care. Goodbye. We'll meet soon.